In today's video, this is video number 1, and we are going to be talking about integers, floats, booleans, strings, and NoneTypes. So these are your primitive types. Now, by primitive, what I mean is that we can't break these values down further into other types. So they're kind of the building blocks of the programming world. Now, in Python, each of these primitive types is associated with the value, which is the exact thing that it represents. So let's think of cars. If I see somebody's car, well, the type of this object is a car, but the value of this object is the exact car that you see with that license plate, with, that exact steering wheel or color or whatever. I don't really know cars. Today's video is sponsored by Brilliant. Brilliant is a platform that allows you to learn interactively in different areas such as math, science, and computer science. And best of all, you can get started for free. So sign up with my link in the description below, and the first 200 people to sign up will get 20% off an annual premium subscription. Welcome to my Python course. In this class, I'm going to be teaching you guys Python from the very beginning, such as primitive types and values, variables, etc., all the way up till the point where hopefully you don't need to watch YouTube videos anymore in order to code. For the purposes of this course, so that we don't have to set up everybody's Python environment, we're going to use a website called replit.com. And on replit.com, we can create a REPL. We're going to select Python. And for the title, let's name it something descriptive. So, for example, for the specific class, I'm going to say Kylie Intro to Programming. And then I'm going to create that REPL. So now here you'll see that on the left-hand side we have our files. Here we have some space to, type our code. So that's our script. And then here we'll have our console or our shell. So our console, we can type certain things, certain Python statements in there, run them, and then it'll return the answer for that. So 2 plus 3, that's 5. So let's discuss these primitive types further. So the first thing is an integer or an int. Now, when we type 2 plus 3 into our Python console, well, Python saw that this was an integer and that this was an integer. So we've actually already seen our integers. And other integers are, 0 or -12 or 10,000. Integers just represent literally real life integers. They represent how many of something do we have. So here, if I take this, I'm saying, okay, let's use stars to represent something that we're counting. So if I have 2 stars and then I add 3 stars, well, how many stars is this now? 5 stars. So for this specific example, we can't have half of a star. That doesn't really make sense to us. And that's the intuition of an integer. It's sort of this variable, this type that, sorry, not a variable. It's this type that you use kind of to count in Python. Now, the second Python type we're going to talk about is also a different type of number. So this is known as a float. And these are used to represent decimal numbers or real numbers. So the most common way to specify if a number is a float is using a decimal point. So if I have 5.0, this point makes that a float and not an integer. If I have, 6.2831, this is also a float. Or even if I just have 3 dot. Now this is a float and not an integer. Okay, so if we go over to Replit, if I type 3 dot, you'll see that this gives me 3.0, 5.0, 5.0. And now one thing that we can do in Python is we can actually ask for the type of something by just typing type, and then in parentheses, give, Python what you want the type of. So if I say 5, then it tells us, you can ignore this class in the brackets, but it tells us this is an integer. Now if I do type 5 dot, so remember this decimal point, what should it be? It's a float. And you guys might wonder, okay, why is it called a float? Not, a real or exact or decimal. Like float seems like a pretty interesting name, right? Well, it's because that with our computer, so real numbers are infinite, but our computer, it's really bad at handling infinite. And so these values are actually represented in our computer using something called floating point. And now this is kind of an aside, so you don't really need to know this, as a beginner programmer, but sometimes this representation can't represent all real numbers. So if I go over here and I type in 0.1 plus 0.1 plus 0.1, you might expect this to give us 0.3, but let's see what actually happens. We have all these zeros and then a 4 at the end. This is because Python is making small approximations with our real numbers, and it just so happens to tack on all these little zeros and 4 at the end. I'll let you read more about that if you want, but let's continue on with our course. Okay, so the next type that I wanted to discuss is known as a bool or a Boolean. So with a bool, there's only 2 different values for this. There's true and there's false. And notice how I capitalized the first letter of these 2 values. So Booleans in Python are literally telling the computer, hey, this thing is true, or hey, this is false. We'll talk about this a little bit more later, and hopefully it'll make more sense. Okay, so then the next type that we're going to discuss is known as a string. So a string is kind of a sequence of characters. It's used to represent a sequence of characters. And we can use single quotation marks around something. So I can say hello, or I can use double quotation marks. So it doesn't really matter in Python which one you use. I can say Kylie. And now both of these are a sequence of the literal characters like this. So actually, something that I like to do with the iPad is I like drawing out this representation. So here for this hello, I'm actually going to literally draw a sequence of characters. So here, the first thing that we have is an H, and then E, and then we have an L, another L, and then an O. Okay, and then for Kylie, we kind of have the same thing, but instead we have a K, Y, L, I, and E. And let me put quotation marks around these so you guys know that these are characters. All right, so this is kind of a visual representation in my head of what a string is. It's stitching literal characters together. So actually, if I have a string 78 like this isn't the number 78 in any way. In fact, it's not really related to that at all. Instead, it's just a sequence of a character that's the character 7 and then the character 8. It's very, very literal. They're not the numbers. It's just saying, this is, you can treat this as any other letter of the alphabet. And now finally, we have NoneType. So there's only one value that this actually takes on, and that is the value none. Okay, so none is a very special object that is designed to represent the absence of a value. So it's almost the equivalent of 0 when, you're talking about numbers. So 0 is kind of representing, the absence of something. And actually, the number 0 felt very weird to many civilizations when it was first invented. But hopefully, it will come to make sense with some time. Okay, So these are actually all the basic types in Python. Now let's see what we can do with these. We are now going to talk about operators. Okay, so with operators, first we're going to discuss the numerical ones. Numerical operators. You've already seen one of them actually, and that's addition. So we denote addition with a plus. So remember how, if we typed into the console 2 plus 3, we got a 5 out. Well, that's addition. But we can also have subtraction, which is just a minus sign. We can have multiplication, which we'll use the star sign on our computer. We can have division, in which we'll use the slash. I always get the backslash and the forward slash confused, but the slash. And then we also have the exponentiation operator, which looks something, it's actually 2 stars. But basically, if I have I star star j, then this is representing I to the jth power. Okay, so that's just an exponent. So if I have, 2 star, actually, I'll show you on the computer. All right, so now in action, well, we've already seen 2 plus 3, but let's say, we have negative 256.3 plus 67. Well, our computer can calculate that. And note that, a float plus an integer will return a float. I can also do subtraction, so I can do 10 minus 3, and that'll give me 7. I do multiplication, so 3.14 times 5 is 15.7. And remember, this is an approximation. I can do division, so 6 divided by 3 gives me 2. And then finally, exponentiation. So if I have 2 to the 3rd power, well, that's 2 times 2, so that's 4 times another 2, so that's 8. And I get 8 right here. Okay? A few other things that I did want to note, though, is that with division, we also have some pretty cool operators that come along with that. So actually, there's also this operator and a double slash operator. So if I do 10 and then this percentage sign, let's say 4, it gives me 2. Actually, that was a bad example. So let's do 10 and then this percentage sign 3. Okay, it gives me 1. So this here is the remainder. Okay, so basically 3, okay, you can do 3 times 3 times 3, and that'll give us 9. Now, what's the remainder if we do 10 divided by 3? It's 1. Okay, so if I have 17 with this little division sign, let's say 5, then I have 2 because 3 times 5 is 15, and then we have this plus 2, which is the remainder, to get to 17. Now, you might be able to guess what this double slash is from that. So if I do 5 double slash 4, I get 1. And actually, that was also a bad example. If I do 5 double slash 3, okay, I get 1. Now, if I do 6 double slash 2, I get 3. So what's going on here? These might not be the best examples. 7 double slash 2, I get 3. So it's basically how many times can the number on the right-hand side go into whatever's on the left-hand side. So it's the opposite of the remainder. There are 3 times of this number that can go into 7 before we hit a decimal. I guess a better way to explain this would be truncation. So this is truncation. So take the number on the left, divide it by the number on the right, and remove whatever the decimal is. So 7 double slash 2. Okay, well 7 divided by 2 is 3.5, right? But we don't care about, the decimal point and after that. We just care about 3. Okay, so that's what this operator is. All right, so those are our numerical operators. And just like in mathematics, this actually follows our PEMDAS rule. So P stands for parentheses. So when we operate on our numerical values, whatever's in parentheses comes first. And then we operate on the exponents. And then we do the multiplication. Multiplication. And then we do division, addition, and subtraction. So let's take an example here. Let's look at something like 5 plus 2 times 4 minus 1 plus 4 to the power of 3, and then close that parenthesis. Okay, well, first we operate within the parentheses. So first we're going to do this part. All right, well, we see another parentheses right here. So what is 4 minus 1? Well, this is equal to 3. So Python is going to operate on that first. So here, this gets replaced with a 3. Now, then we have exponentiation, right? That's second here. So 4 to the power of 3, let's see, 16 times 3, that should be 64. So this here, I will replace with 64. And then, well, next we have multiplication. So 2 times 3, that's 6. And then the parentheses now reduces to 70, right? So I can replace all of this with 70, and we get 75. So let's go over to our console and see what we get. So we get 75, and it's exactly because of PEMDAS. All right, then let's talk about our string operators. So we can't perform mathematical operations on strings, even if they look like numbers. So for example, let me clear this. If I have string A minus string B, do you think that this really makes sense? Does it make, what does it mean to subtract a string from another? Well, Python answers that question for us because it tells us, okay, this isn't going to work. So even if my values look like numbers, Python is going to say, I don't like that. It's not going to work. Okay, so if I do 80 divided by 3, Python doesn't like this. But there are 2 exceptions. And the first exception is that we can actually add strings together, and this becomes something known as string concatenation. So we can concatenation. So basically, if I take A plus AB plus C, so what this is doing is saying, all right, let's say I have my character A, and then I have my characters A, B, and then I have my characters C, right? So what string concatenation is doing is saying, okay, just concatenate, add all these things together so that we can get a new string where the values are A, oops, it's not B, it's A, B, and C. So here in my console, if I do this, you'll see that this is exactly what we get. Ta-da! And in fact, I can even do hello plus Kylie. Take a minute, think about what this would give you. So this gives hello Kylie, but without any spaces. And this is because Python takes spaces very literally. A space will occupy one of the little boxes that I drew. So in order to get, hello space Kylie, I literally have to put a space inside the string like this. And now you'll see that I have a string for hello Kylie. Okay, now similarly, we can actually do string I'll call this multiplication by a number. And not just any number, it has to be by an integer. So string, and then I'll put the multiplication marks in quotations. That doesn't mean it's a string here. It's just multiplication. So if I have AB, I can actually say, okay, let's multiply that by 3. And just like how in math, when we have 2 times 3, what this actually is 2 plus 2 plus 2, right? It's 2 3 times. This is going to be AB 3 times. So in fact, what this gives us is AB plus AB plus AB. And that gives us AB, AB, AB. All right. Let's see that in action. So if I say hello times 3, you get hello, hello, hello. If I say XYZ space times 5, you'll see that it's XYZ, 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 XYZ space. So those are some of our string operators that we can do. And actually, check this out. If I do 7 plus 8, what do you think would happen there? Well, if you said that we got a string 78, you would be correct. And the reason is because when I have that, I have 7 plus an 8, both as literal characters, which gives me a string of characters 7 and 8. Okay? And similarly, if I have, 3 times 3, well, that's not going to give me 9. That's going to give me 333 as a string. Now let's move on to Boolean operators. So remember, our Booleans were true and false, and that's literally it. We can actually see if two things are equal to one another, if they're not equal to one another, if they're greater than, less than, etc. So let me go back to the screen, my console, and show you guys how some of these operators work. So the first one is the equality operator. So I can have 5 double equals to 5, and that would give me true. So this is an operator. And I can do this for, any of the types. I can say, hey, is 5 equal to A? Well, are they equal? Not really, right? So Python is going to tell us false. Well, what about BC? Is that equal to BC? That's true. And you'll also notice that if I add in the quotation marks, single or double, it doesn't really matter in this case. We can also ask, hey, are these not equal? So I can say, hey, is A not equal to 100? And let's make it a float just because. And that's going to be true because A is not equal to 100, right? 100, is that not equal to 100? That's false because 100 equals 100. We can also do greater than or equal to, less than, and less than or equal to. So is, 5 greater than 3? This little sideways caret is our greater than sign, and that's true. Okay, is 5 greater than or equal to 3? That's true. Is 3 greater than or equal to 3? It's true. It's true because 3 is equal to 3, right? And now we can do less than as well, and this will be false because 5 is greater than 3. Well, okay, and let me just do 3 is less than or equal to 5 for the sake of this example. That'll give us true. And now let's do 10 is greater than or equal to 3. That's false. Okay, so those are our Boolean operators. We have is equal to, and that would be this double equal sign. We have not equal to, and that would be this exclamation mark equal sign. We have greater than, which is this caret, greater than or equal to, and that's this caret plus this equal sign. Less than is this less than, and then we have finally less than or equal to. And that, as you can guess, is this less than caret, and then equal to. So there are also 3 different operators that only operate on Boolean values. So those are and, or, and not. So what this is saying is, like, let's say I have something and something else, and these operate out to, true or false. So these are both true, false values. Does this give me true or false in the end? So let's say whatever this Boolean is A, whatever this Boolean is B, and let's draw out a chart for this. So let's say A is this row up here, B is this row down here. So if I have true, false, and then true, false, so if both of them are true, then this is true. However, if any part of this here is false, then we actually automatically get false for the other ones. So and is saying that both of these have to be true in order to be true, and in any other case, the rest of these are false. Well, for or, let's say now this is A or B. Let's draw out the chart for that. Okay, so this is A up here in the top. This column is B. So here, if B is true, B is false. A true and A false. So if something is true or something else, so or is basically, it's literally asking you, hey, is A true or B true? Are either of these true? Well, if both of them are true, then it's true, right? Well, what if only one of them is true? It's asking, hey, is either this one true or this one true? Then, yeah, it's still true because it's only asking if one of them is true, right? But now what if both of them are false? Okay, well then that's false. And similarly, you can think of the and as asking, hey, is this true and is this true? Is A true and is B true? If both of them are true, then yeah, that's right. So that's true. Otherwise, they're all false. So here I'm going to say, hey, this is false over here. But the rest of these are good when they're, when there's at least one truth. Okay? And then not is a little bit simpler. So if something's not false, well, then it's true. And if something's not true, well, then it's false. Okay? If I go to my computer, you can see some of these some of these examples. So true and true is true. True and false is false. False and false is false. Now true or true is true. And when one of these is false, it's still true. And if both of them are false, then it's finally false. So now I can also do, not true. Okay, that's false. If it's not false, okay, then it's true. So these are our Boolean operators. Now, in this class today, what you've learned so far, you have learned your basic types, and you've learned how to basically use these types and use operators in order to get Python to do some work for you. Just take a moment and pause and think about what would happen here. This is the extent of interactive learning content on YouTube. So that brings me to today's sponsor, Brilliant. Brilliant is a platform where you can actually learn interactively, so you can learn by doing instead of just watching. So Brilliant has a bunch of different courses that you can choose from, ranging from beginner to advanced. So it doesn't matter how old you are, what ability you have, Brilliant probably has a course for you. So I went and checked it out. One thing that I really like about Brilliant is that they have these really clear and intuitive explanations along with pictures that help me visualize what's actually going on. And whenever I learn about these things, I'm always forced to think about, what's actually happening. So it's helping me develop logic and not just memorizing different topics. So if you guys are anything like me and you like learning about new things in science, math, and technology, I highly recommend giving Brilliant a try. And the best part is you guys can get started for free today. The first 200 people to sign up will get 20% off an annual premium subscription. I've already posted a link in the description below, so all you have to do is click it, sign up, and get started.